Okay, this is another example. I'm giving you the word equation and I say, guys, can you please get all the possible mole ratios from that? Okay, so I'm giving you this wait. Okay, good, good. It's that in the last class it didn't function, okay, when I was working. Okay, so take a look. I'm giving you another example. Okay, example two. Example two. Iron plus oxygen gas produce iron 3 oxide. First of all, what you have to do is write in the chemical reaction, okay? In using the symbols, okay, the chemical symbols. For iron, you know that we have Fe. For oxygen gas, you know it's just O, because oxygen is a diatomic molecule, okay? It is diatomic. So what you have to do is put the 2 as a subscript, because remember, it's diatomic. Now, what do you have in the product? You have iron 3 oxide. How do we write iron 3 oxide? First, you're going to combine iron 3 with oxygen, that is O2 minus, and you're going to crisscross the charges. So the 3 from iron comes here. I'm going to put it here. And the 2 from oxygen goes to iron. Okay, this one comes here. Janice, can you please turn the microphone off? Thank you. So I'm going to put it over there. Now, that is the reaction, okay? This is the equation that we have. So right now, what we have to do is we need to do the mole ratios. But what you have to do in the first place is this step, you have to check this step always, okay? You have to check if it's balanced. Check if it is balanced. What can you say? Is it balanced? Yes or no? Is the equation balanced? No, it is not. And remember the process I taught you? List all the elements, begin with the metal, then with the non-metals, hydrogen and oxygen. Then there you go, you have failed over there. Now you have to compare what you have in each side of the equation. From iron, you have 1, and for oxygen, you have 2. And in the products, you have 2 and 3. So you need just to do a few adjustments. I'm gonna put 2 over there. So my iron is going to be balanced, but still it's not balanced. So in order to get the 3, I will multiply this oxygen by 1.5 in order to get 3. But I cannot leave that reaction, okay? I cannot leave it at that because I cannot give a decimal number as coefficient. So what I do in the end is I will multiply times 2, all my equation times 2. So this is going to be 4 iron plus 1.5 times 2 gives me 3 oxygen. All these produce. Here, remember that you have invisible 1 over there. Times 2 is going to give you, it's going to give you 2. Invisible 1 gives you 2, okay? 2 fail, like that. Now that it's balanced, now that you check that it's balanced, what we have to do is we can list all the possible mole ratios. So I'm going to list all the possible mole ratios below. Okay, take a look. I'm using ruler to underline the titles. Follow me, follow me. Right now in this homework, I allowed you to not use the margins. I just took 0.5 away if you didn't follow the guidelines, but next time I can take 1 point away. So I don't want to be taking points away for you, okay, for pretty simple things. So the mole ratios. First, I will relate iron, okay? I will relate iron with my product. So I'm going to write it like this. 4 mole of iron produce 2 mole of iron trioxide, okay? Or I can write it, okay? I can just flip the fraction and I can just write 2 moles of iron trioxide are produced when 4 moles of iron take part in the reaction, okay? That's one relationship that you can say. Another one, you can relate the same iron, but now with the oxygen. So let's do it. 4 mole of iron reacts with 3 mole of oxygen. Remember, oxygen is the atomic, so you put it with a 2. Or flip the fraction, and you're going to have 3 moles of oxygen react with 4 mole of iron. That's it. That's one. Those are two relationships, okay? Now you can relate oxygen with a product. What can we say about the oxygen? 3 mole of oxygen produce 2 moles of iron trioxide. Or flip it, and you're going to have 2 moles of the product. 2 moles of the product you'll get after 3 moles of oxygen take part of the reaction. That's it. Now, I can also relate oxygen with iron, but there is a relationship that we already did. Take a look. There, okay? Iron and oxygen are related, like that. So that basically this one is already done. So now that you check that there are all the possible mole ratios written over there, we can say, okay, those are all the possible mole ratios. And we are done with it. So as you can see, the process is pretty simple. Balance if it's not balanced, and then just write all the possible combinations. That's it. Do you have a doubt? Do you have a doubt?
No.
Okay, I will write another example, another reaction for you to see what to do if you have a more complex reaction. Okay, so I have CO2 plus Leo produce liquor. Sorry, that's how I write the equations. Plus water. Yes, water. Okay. Okay, you have a chemical reaction over there, and can we start writing the mole ratios?
No.
No, what's missing?
It's missing to balance.
It's missing to balance, okay? So remember to follow the procedure. It's easier when you do it like that. I know it's not balanced because here I have 2 lithiums and here I have just 1, okay? So I can tell that it's not balanced. So remember the procedure is to list the elements in the order metals, like lithium comes first, then the non-metals like carbon, then hydrogen and oxygen. There you go. We have lithium over there. Lithium. Amazing, las lichas. I miss them so much. And then you start counting the atoms. 1 lithium in the right, 2 lithium in the left, 1 carbon in the, sorry, I don't know what right and left means. 1 lithium in the left, 2 in the right, 1 carbon in the left, 1 carbon in the right, 1 in the left, 2 in the right, 3 oxygens in the left, because I have 2 oxygens here, plus 1, makes 3 oxygens in total. And the other one, oxygen, I have 1 right here, and I have 3 right there, which makes 4 oxygen in total. So you can say net is not balanced. So how can we do this? The process to balance is pretty simple. We start to balance the metal. So to balance the lithium, I just had to put 2 over there. And now the lithium is balanced. Good. But that 2 affects not only lithium, but also oxygen and hydrogen. So right now, my oxygen changes. My hydrogen changes. Now I have 2 hydrogens, and oxygen also changes. I had 3, and now I have 2 plus 2, 4. And now you can see that is balanced. Now that is balanced, we can continue to the next step. That is to list all the mole ratios. Do you have a question so far?
No.
Okay. Now for the mole ratios, remember one thing. When you don't see a number in front before a compound, that means that we have invisible 1. So you can write the invisible 1 like I'm doing here. Okay, because I'm going to need it. I'm gonna need to write the invisible 1 in my mole ratios. Okay, so I suggest you to write it for this kind of problems. So I'm going to list my mole ratios. Okay, so right now I will combine CO2 with Leo. Okay, then with liquid, and then with water. That's what I'm gonna do right now. Okay, I will do the 3 possible combinations. So I say 1 mole of CO2 And I will combine it with Leo. 1 mole CO2 and I have 2 mole of Leo. And then I can write, I can flip it, okay? Or I can say 1 mole of Leo is related to 1 mole of CO2. That's one combination. You can combine now CO2 and LiCO by saying 1 mole CO2 divided by 1 mole of LiCO, like that. Or flip it, 1 mole LiCO is to 1 mole CO2. That's the second combination. There are 2 possibilities. Then combine the last one, which is 1 mole of CO2 with 1 mole of water, or 1 mole of water it's to 1 mole of CO2. Now that you finish to combine all of them, you can erase this and move into Leo. Okay. Now I will combine Leo with CO2, but also Leo with LiCO and with water. I will do all the possible combinations. But take a look here. Leo and CO2. It is a combination that we did before. Okay, it is right here. Leo and CO2, it is the first combination that we did before. So we don't need to do it again because it is already there. You already did it. So this combination doesn't need to be done, okay? So what you do is you continue with the rest of the combinations. So you have 1 mole of Leo, 2 moles of Leo that are combined to produce 1 mole of LiCO. Lithium carbonate if you want to sound more professional. Or you can flip it. 1 mole lithium carbonate is to 2 moles of Leo. You finish the second combination. And now you're gonna work just with the last one, which is 2 moles of Leo produce 1 mole of water, or 1 mole of water are produced when 2 moles of Leo react like that. With this, you already finished another combination. Now, LiCO. With LiCO, I can combine LiCO with CO2, LiCO with Leo, and LiCO with hydrogen. What are the combinations that we already did? And we don't need to do any more because they are done already. What are the combinations that we already did?
First two.
The first two.
Nico with CO2 and Leo. Yes.
LiCO CO2, it's already done. It's here. Okay. And then LiCO and Leo, that is right here. LiCO and Leo, that is right here. Okay. Those are done already. So we don't need to do them again. So we're just going to combine LiCO and water. That's the only possibility that we have to work, that is left, okay? So we say 1 mole of LiCO produced 1 mole of water. And we can also write that 1 mole of water is produced when 1 mole of LiCO is also produced, like that. And now that you finish all the possibilities with LiCO, it's only missing water. Okay, now what happens with water? With water, I have to combine with LiCO, with Leo, and also with CO2. Do I have already those combinations?
Yes.
I have them already, okay? I have water and CO2 is right here. So you can delete it. You have water and Leo, which is right here. Water and Leo, it's right here, okay? So we can erase it. And LiCO, water, it's the last one that we did.